The one we've been looking at is standard form, the ax squared plus bx plus c. But sometimes it's written in what's called vertex form. So you might see it written as a times x minus something squared plus something. Okay, a, h, and k here represent numbers. When you see it like this, we don't have to do the whole formula, opposite of b over 2a, to find the vertex. We can actually identify the vertex just by looking at this formula. The x value of the vertex is the thing that gets subtracted from x. So that's your h. The y value is the thing that gets added onto the end. That's the k. Axis of symmetry is always x equals the x value of the vertex. So x equals h. So these, it's just faster to find the vertex. There's no doing opposite of b over 2a and then plugging that back in to get the y value. We can just look at it and tell when it's written this way. All right, so we're going to first just practice looking at these equations and seeing if we can pick out the vertex and axis of symmetry. So everybody look carefully here. This first one, in my parentheses, it's x plus 4. But the formula has to have minus. So think of it as the opposite of this number. Or think of it as x, what would you have to plug in for x to make that equal 0? So my x value is negative 4. So the axis of symmetry, it's the opposite of this inside, or what makes it equal 0. So it's negative 4. Make sure on the axis of symmetry you type your x equals. Vertex is an ordered pair. The x value of the vertex is what we just found. The y. Okay, the formula, it should be a minus h plus k. So if there's a minus 2 on the end, it's negative 2. So it's always the opposite of what's in the parenthesis and the same thing on the outside. So when I look at number 2, my axis of symmetry, x equals, what makes x minus 3 equal 0? Positive 3, so x equals 3. So my vertex, the x value is 3. The y value is what's added onto the end. If there's nothing there, it is 0. When I look at 3, my axis of symmetry, it's just like setting this x minus 5 equal to 0. If you do that, you get x equals 5. So the axis of symmetry is x equals 5. Axis of symmetry is x equals. Vertex, we have the 5. The y is just what's tacked on the end. So that's the minus 4. Number 4, axis of symmetry. It's supposed to be what makes this inside 0. But it's just x. So this time, my axis of symmetry is x equals 0. There's nothing added or subtracted to it. So because the 2 is multiplied, it's not added or subtracted. That doesn't count. My vertex is 0, and the y is what gets added onto the end, which is positive 3. Okay, what questions do we have right there? So if it's written in vertex form with the parentheses, we can just look at it and identify the vertex, which means it's faster to graph it in this form. Let's actually do a graphing one. So if I look at number 5, axis of symmetry is the inside. If you set x plus 2 equal to 0, you subtract your 2 over and you get x equals negative 2. So the axis symmetry is just always the inside equal to 0, and solve it. That gives you the x value of your vertex. Where do I find y?
What are you adding on to it?
I'm adding 7, so the y is positive 7. So just like yesterday, we put that in the middle of the table. Negative 2, 7. All right, and then what did we do yesterday to get the rest of our points? Yep, we did numbers smaller and numbers larger. So smaller, be negative 3, negative 4, things bigger, negative 1 and 0. Everybody should be taking notes right now. The amount of homework you're going to have in a little bit is directly correlated to how much work you do right now. If you're not even going to bother writing this down, then I will keep you in advisory, and I'll even pull you out another class later in the day if you need to come in and do something. Yes.
How far are you racing?
All right, what did we do yesterday after we had all of our x's? All right, you guys do negative 4, you guys do negative 3, you 3 do negative 1, and you guys do 0. You're plugging them into the equation. So when you type it in your calculator, you have the negative in front, parenthesis, whatever number you're plugging in, plus 2, close your parenthesis, to the second power, plus 7. What did you get when you put in negative 4? What did you get when you plugged in negative 3? 6. What did you get when you put in negative 1? 6. And what did you get when you plugged in 0? How do you know that you're getting the right things? Yeah, they match up. The vertex is the middle. We're getting the same thing on both sides. Okay, so we have negative 2, positive 7. Make sure you're connecting your dots, and it keeps going. How did we know at the beginning that this one was going to open down? There's a negative in front. What's the domain always? All real numbers. So you can either write out in words all real numbers. The symbol for all real numbers is an R with a double bar on it. So either way. The range, if it's opening down, we're hitting everything smaller than, so less than or equal to this high point. My y at that point was 7. So my range is less than or equal to 7. So the only difference from yesterday is we can just look at this and find our vertex and axis of symmetry. Then the rest of it, plugging in to get our values, is the same. So we don't have to do the opposite of b over 2a. We can identify it from the equation. Number 6. To find the axis of symmetry, you just take the inside, set it equal to 0. So you add your 1 over, and you get x equals 1. So the x value of the vertex is 1. How do you find the y value? Yep. whatever's added onto the end. If there's nothing there, what is it? 0. Not adding anything. Okay, so 1, 0 is the middle. Numbers smaller than 1, 0 and -1. Bigger than 1, 2 and 3. Plugging these into our equation. So you're doing 3 parentheses, whatever number you put in, -1 squared. Alright. First row, you guys do -1. You guys do 0. You guys do 2. And you guys do 3.